In plain polarised light, the grains have low relief, which means that they don't stand out from the section. In this thin section, the pore spaces have been vacuum impregnated with blue stained resin so that they are easily recognised in plain polarised light. The grains are less than 2 mm across and are well rounded to sub-rounded and form subspherical grains. They show a small range of grain sizes, so the rock may be described as well sorted. In the thin section, there is no apparent orientation of the grains. Grain boundaries are touching, and there are very few long edge grain boundaries. Grains are of two main types. In plain polarised light, most grains are colourless, but there is another grain which is yellow. This colour was produced when the thin section was placed in a sodium cobalty nitrite solution, which stained the grains of potassium-rich feldspar, or K-feldspar, a yellow colour. The colourless grains show no cleavage. When the stage is rotated, these grains show no change in colour, which means that they are not pleochroic. These grains are made of the mineral quartz. Original grain boundaries are shown by the red-brown lines. This red-brown colour is caused by the grains being coated with a thin clay layer that has been stained by hematite. Hematite is an iron oxide mineral. The mineral forming these grains is quartz. And you can also see that quartz has formed as overgrowths into the pore spaces. In plain polarised light, the mineral that is stained yellow, and which is potassium-rich feldspar, tends to form well-rounded grains. As the stage is rotated, it does not change colour, which means that it is not pleochroic. The feldspar grain boundaries are also marked by red-brown lines. This is because these grains are also coated with a thin clay layer that has been stained by hematite. Note that there are no quartz overgrowths into the pore spaces surrounding these feldspar grains. Under cross polars, the quartz is identified by its first-order grey interference colours. It also shows no twinning. The hematite grain coatings on each grain are shown as a fine dark line on the edges of the original quartz grains. Some of the quartz grains have straight extinction. Others show an undulose extinction, which means that it goes into extinction in a wavy pattern. Note that the overgrowths of quartz on the quartz grains have the same extinction pattern as the quartz grains that they surround. Some of the grains are composed of multiple intergrown quartz crystals. Under cross polars, where visible in stained grains, these feldspar grains have first-order interference colours and show extinction inclined to long grain edges. Unfortunately, the staining affects how clearly these details can be seen. In summary, this rock sample is well sorted and texturally mature because it has a small range of grain sizes and is generally composed of well-rounded to sub-rounded grains. It is also mineralogically mature because it has a small number of different minerals and is largely composed of quartz, which is a mineral stable at Earth's surface. This indicates a source of grains far from the place of deposition, or a distal source. The mixture of different types of quartz grains may indicate more than one source. The hematite-rich clay marks the original grain boundaries. The point contact and few long edge grain boundaries with no deformation of elongate grains around the subspherical grains indicates little or no compaction before cement's formed. The quartz overgrowths indicate a stage of post-depositional cementation which occurred without completely blocking the pore spaces. This rock is a sandstone that may be described as a quartz arenite.